mass 1 over that distance is equal to mass 2 over the other distance squared. Now I have to solve. I do know one other thing. In most of those problems, I know that distance. I have mixed it up before, and I've given this distance, and you have to figure out what that is, but. So, why don't I make that x, and so this would be whatever that distance is. Is it 8 meters in the problem? That would be 8 minus x. So you're left with m1 over x squared is equal to m2 over 8 minus x squared. And now it's a math problem. M1 and M2 were given, so your only unknown is an x. One equation, one unknown. What could be better than that? Now, for those who have worked through it using they cross multiply, they expand this out, they end up with a quadratic. You're going to get 2 answers. You'll get a positive answer and a negative answer. What does the negative answer mean?
That's how far away from the masses for it not to influence.
No, there's still influence there. All right, so let's just all make up some answers here. I'll keep it at 8 meters apart. So if they're 8 meters apart, and we define x like that, and we end up with x is, we'll just say 2 or negative 15. X is equals 2. The force in both these two forces are equal in magnitude, just pulling apart, pull opposite direction, they are canceling each other out. Therefore, it's equilibrium. Where would negative 15 be?
On the left side.
Okay. So what's happening here? Which way will the two gravitational forces be acting on this? Are you thinking, Olivia, or are you giving that answer?
Wouldn't it be to the right since they're both to the right and pointing towards it?
Yeah, gravitational force attracts, so it's being attracted to both of them. But why negative 15? Why not, besides the fact that I just made it up, assuming that's a correct answer, why would that special there, why not, negative 1 million?
Isn't that the position that it's at?
Pardon?
Isn't that the position that it's at?
No, what do you mean by that?
I don't think that's right.
Equilibrium's here. This is not going to be an equilibrium out here,
Right.
but it's still a mathematical answer.
It's. Is it too far away, I would say?
Oh, you mean as in they're beyond the gravitational pull?
Yeah, of that one, on the very.
Oh.
Yeah.
No, in classical physics, you're never beyond gravitational
Oh,
pull.
okay. Just kidding.
It's not until you get into semi-modern physics where you suddenly have to take into account that whatever signal is being sent back and forth to cause gravitational force can't travel faster than the speed of light. So,
If the masses are different sizes, 1 and 2, would that position of negative 15 be where they are having the same amount of pull?
yes. Here, the poles have the same magnitude but opposite direction. Here, they have the same pull and the same direction. Or if you got an answer of x is equal to something bigger than 8, the same thing, it's just a matter of which one's bigger or smaller. Presumably, if it's up over here, this is the smaller mass, because it needs to be closer to get the same pull as that one does. If it's over there, that one's the smaller mass. So not an equilibrium, but there is a physical meaning to that second number. Or you could avoid that and come up with only one answer by just taking the square root of both sides. And that gets rid of the second solution. Taking the square root of both sides only works if you've correctly identified where it's going to be. I know it's in the middle, that's x, that's 8 minus x. If I know this it has to be in the middle, then I can get away with just doing the square root of both sides. Anything else on this problem? All right, you just feel the energy, the electric excitement. Other questions? Okay. Moving on. Let's see. Oops. Come on. It won't let me stop it.